China has transformed its military landscape over the past few decades. Videos from state broadcasters reveal sleek drones soaring through the sky, rolling across rugged terrain, and gliding beneath the waves. These displays signal a bold message. China has made massive strides in developing military drones for air, land, and sea. Experts point to one key factor driving this progress: artificial intelligence. By equipping drones with advanced AI, China aims to challenge the United States, long the world's leader in military technology. How did a nation once lagging far behind catch up so quickly? To understand, we must rewind to the early 2000s, when China began its military modernization with a clear goal: rival the United States. The United States has dominated military innovation for decades. Its arsenal boasts more combat aircraft, armored vehicles, and aircraft carriers than any other nation. Drones like the Reaper, used for precision strikes, and the Global Hawk, a surveillance powerhouse, set the standard for advanced unmanned systems. China, however, saw an opportunity. While the United States focused on conflicts in the Middle East, China seized what it called a window of strategic opportunity to build a force capable of competing with the world's superpower. This ambition wasn't just about matching numbers, it was about creating drones that could think, adapt, and overwhelm. China's journey began with the hardware. To compete with the United States, China needed drones capable of running sophisticated AI software. Instead of starting from scratch, China studied American designs. The Wing Loong drone, for example, mirrors the capabilities of the United States Reaper, designed for offensive strikes with pinpoint accuracy. Similarly, the Soaring Dragon closely resembles the Global Hawk, built for long-range surveillance. These parallels are no coincidence. China reverse-engineered and adapted American technology to create its own versions, often at a lower cost. Beyond copying, China diversified its drone portfolio. Both nations now develop unmanned systems for multiple domains. Unmanned surface vehicles and submarines, for instance, can conduct surveillance, lay mines, or fire torpedoes at enemy warships. On land, robotic dogs, small, agile drones, can assess threats, carry weapons, or handle explosives while keeping human soldiers safe. These machines, though less glamorous than fighter jets, are critical to modern warfare. They reduce risk to humans while extending a military's reach. China's edge, however, lies in smaller systems. While the United States leads in large military drones, China dominates the global market for consumer-grade drones. Companies like DJI, a Chinese firm, control nearly 3/4 of the worldwide drone market. This dominance translates into a key advantage: China can produce small and mid-sized drones cheaply and at scale. These drones may not match the firepower or range of larger systems, but their affordability makes them ideal for mass deployment. In contrast, the United States has struggled to produce reliable small drones in large quantities. This gap became evident in the Ukraine war, where both sides relied heavily on DJI drones, despite the company's stance against their use in combat. China's strength in small drones opened a new frontier in warfare: swarms. Imagine dozens, even hundreds, of drones, on land, in the air, or at sea, working together as a single unit. Powered by AI, these swarms can overwhelm an opponent or complete complex missions. Even if some drones are destroyed, the swarm continues, adapting in real time. Videos from China show drones coordinating to locate and strike targets, a capability that has caught the attention of military experts worldwide. The United States has explored swarm technology, but only in training exercises. China, with its advantage in producing affordable drones, appears better positioned to deploy swarms in real-world scenarios. This approach doesn't require each drone to be a technological marvel. Instead, the collective power of many simple machines, guided by AI, creates a force far greater than the sum of its parts. For example, in a hypothetical conflict over Taiwan, swarms could flood the battlefield, overwhelming defenses with sheer numbers. Another strategy, called drone stacks, has already seen combat. Unlike swarms, Drone stacks involve individually controlled drones performing specific tasks in sequence. One drone might identify a target from afar, another confirms it up close, and a human operator makes the final call to strike. AI plays a limited role here, perhaps aiding with navigation or collision avoidance, but the process is slower and less autonomous than swarms. Drone stacks require nearly as many human operators as drones, making them less efficient but easier to control. Both approaches highlight a key truth: drones are only as effective as the sensors they carry. Drones rely on sensors to see the battlefield. Standard optical and infrared cameras are common, but advanced systems use synthetic aperture radar to detect ships through clouds or electro-optical sensors to track moving targets. In a potential Taiwan conflict, where visibility could be limited by weather or electronic jamming, these sensors would be critical. The side with better intelligence, knowing where the enemy is and what they're doing, holds the advantage. China has invested heavily in sensors, aiming to give its drones an edge in gathering real-time data. The United States, meanwhile, is exploring a different approach: collaborative combat aircraft. These AI-equipped drones support human pilots by gathering intelligence or delivering weapons. A fighter jet paired with such a drone becomes less vulnerable, as the drone can carry out high-risk tasks. This strategy suits the United States' strength in advanced, large-scale systems. China, however, could leverage its proximity to Taiwan, launching drones from nearby shores, while the United States would need longer-range drones to operate from distant bases. China's drone advancements are part of a broader military strategy launched decades ago. The plan unfolds in three phases: mechanization, informationization, and intelligentization. Mechanization reduced the need for large troop numbers by emphasizing advanced weapons. China claims it has achieved this goal, with drones playing a central role. Informationization focuses on building surveillance networks to control battlefields and connect military platforms. Satellites, radar, and drones feed data into a centralized system, giving commanders a clear picture of the fight. The final phase, intelligentization, is where AI comes in. By speeding up decision-making and communication, AI could transform warfare. A drone that can analyze data, adapt to threats, and act without human input is the ultimate goal. While fully autonomous drones are still years, if not decades, away, China is moving faster than many expected. State media showcases drones with increasing autonomy, hinting at a future where machines could dominate the battlefield. The race for AI drones raises tough questions. The United States insists on keeping humans in the loop for lethal decisions. Pentagon policy holds that humans must authorize the use of force by autonomous systems. This stance reflects ethical concerns about machines deciding who lives or dies. But China may not share these constraints. Experts warn that nations without such guidelines could deploy fully autonomous drones faster, gaining a strategic edge. The fear is that a drone could strike without human oversight, escalating conflicts in unpredictable ways. This ethical divide complicates global efforts to regulate lethal autonomous weapons. The United States has resisted bans on such technology, knowing that adversaries like China are unlikely to agree to restrictions. Meanwhile, China's state-controlled media rarely discusses the ethical implications, focusing instead on technological triumphs. This silence suggests a willingness to prioritize capability over caution. Cost is another factor shaping the drone race. A single U.S. fighter jet can cost $100 million, while a DJI drone might cost just a few $100s. This price gap allows China to field vast numbers of drones, even if they're less advanced individually. The United States, with its focus on high-end systems, faces challenges scaling up. Programs like the Air Force's Collaborative Combat Aircraft and the Department of Defense's Replicator Initiative aim to develop AI-driven drones, but both are still in early stages. Fully operational systems aren't expected until later this decade. China, by contrast, has already integrated drones into its military exercises. Videos show swarms performing complex maneuvers, from coordinated strikes to reconnaissance missions. These displays aren't just propaganda, they demonstrate real capabilities. China's ability to produce drones at low cost, combined with its AI advancements, has narrowed the gap with the United States faster than many predicted. Recent tests highlight the potential of AI drones. In a U.S. Air Force experiment, algorithms faced off against human pilots in simulated dogfights. The results were striking. AI held its own, showing it could match human skill in certain scenarios. While these tests are early, they point to a future where drones could replace human pilots in some roles. For China, this aligns with its goal of reducing reliance on troops while maximizing technological impact. The implications are staggering. A fleet of AI drones could reshape warfare, making it faster, cheaper, and more precise. But it also raises risks. A miscalculation by an autonomous drone could spark a conflict neither side intended. In a Taiwan scenario, where tensions run high, drones could escalate a crisis before humans have time to react. Both nations recognize this, yet the race continues, driven by the fear of falling behind. China's drone program is still evolving. While it has caught up to the United States in many areas, truly intelligent drones, ones that operate fully independently, are likely years away. Current systems, like the Wing Loong and Soaring Dragon, rely on human oversight for critical decisions. But the pace of progress is relentless. China's investment in AI and sensors suggests it won't stop at matching the United States. It aims to surpass it. The United States, meanwhile, is doubling down on its strengths. Programs like Replicator focus on building drones that can operate alongside manned aircraft, leveraging America's edge in advanced technology. But the challenge is scale. Producing enough drones to counter China's numbers will require a shift in strategy, one that prioritizes affordability without sacrificing capability. The drone race is more than a technological contest, it's a test of vision. China's three-part plan has given it a clear roadmap, while the United States grapples with balancing ethics, cost, and innovation. Whoever masters AI drones first will hold a decisive edge, not just in battles but in shaping the future of war. The skies, seas, and battlefields of tomorrow are already taking shape, and China's drones are flying closer to the forefront than ever before.